and it can accelerate a 2-ton car to 60 miles an hour in 2 seconds. The RPM is so crazy that just the centrifugal force wants to expand the rotor.
You think the electric car revolution has already been decided? Well, think again. Elon Musk just dropped a bombshell, a new powered motor engine so advanced, it doesn't just compete in the EV game, it redefines the game entirely. No gears, no delay, no mechanical drag, just pure, seamless velocity that feels more like you're riding a lightning bolt than driving a car. We're talking about a motor so compact you can lift it by hand, yet powerful enough to launch a family sedan faster than a Lamborghini. A rotor spun at over 20,000 revolutions per minute, wrapped in carbon fiber so tight it could survive a small-scale apocalypse. This isn't an upgrade. It's a revolution, and it's so fast the laws of physics might need a rewrite. And here's the kicker. It's not just about speed. It's about efficiency, cost, and total domination. So, how did Tesla pull this off? What's hiding behind the sleek shell of the world's most disruptive EV? And what does it mean for every other car company scrambling to keep up? Strap in. The ride doesn't start now. It's already left them all in the dust. This wasn't just an upgrade. It was a declaration of war. For over a decade, Tesla has led the EV race, sometimes by a mile, sometimes by a whisker. But in typical Musk fashion, they didn't just turn up the dial this time, they ripped the dial off the dashboard. The weapon? A motor so radical, so compact, and so ferociously efficient that it doesn't just outperform competitors. It threatens to make their entire approach obsolete.
Make everything else obsolete.
And it can accelerate a 2-ton car to 60 miles an hour in 2 seconds.
Unveiled during the Model S Plaid delivery event in June 2021, this motor looked deceptively small. So small, a single engineer could lift it unaided. But what it lacked in size, it made up for in brute force. It could send a 2-ton family sedan flying from 0 to 60 in less than 2 seconds. Let that sink in. A 4-door car that accelerates faster than a Bugatti. But the magic isn't just in what it does, it's how it does it. At the heart of this drive unit is something Tesla calls a carbon-sleeved rotor, a term that sounds almost sci-fi, and honestly, it kind of is.
There's just never been an electric motor like this. I mean, you could pick this motor up with your hands.
Traditional electric motors struggle with heat and structural stress at high RPMs. Their metal parts expand, grind, and eventually fall apart. That's why most electric motors cap out at around 16,000 RPMs. Tesla's? It blows past 20,000 with chilling precision. The secret lies in the carbon fiber wrap. Using a proprietary high-tension process, Tesla engineers pressurize the copper rotor with a carbon sleeve, so tight it acts like a permanent clamp, compressing everything inward. This keeps the rotor perfectly centered even at insane revolutions, preventing micro wobbles and loss of energy. And here's the kicker. This carbon wrap also stabilizes the air gap between the rotor and stator, an ultra-thin space where magnetic magic happens. What does all this techno jargon mean for the driver? More torque, less heat, lower weight, faster spin, more durability. It's not just engineering, it's engineering with vengeance. In performance tests, the Plaid's tri-motor system delivered over 1,020 horsepower and more than 1,050 foot-pounds of torque. That's hypercar territory, but in a sedan with cup holders and Netflix. Even more shocking? The cost. At Tesla's 2023 Investor Day, they revealed that the next-gen version of this motor would use 0 rare earth materials, 75% less silicon carbide, and cost just $1,000 per unit to manufacture. For context, that's less than what some competitors pay just for their cooling system. And speaking of cooling, this motor barely needs any. Unlike legacy EVs that chew through battery and airflow like a furnace, Tesla's design is hyper-efficient, converting almost all input into clean propulsion. No oversized radiators, no industrial fans. Just motion. Clean, quiet, explosive motion. In a world where EVs are often forced to choose between power and range, Tesla just said, why not both? And that's the genius. This motor doesn't force compromise. It delivers brutal acceleration without sacrificing efficiency. It balances speed with stamina. And most importantly, it does so at scale. These aren't prototypes. They're rolling off the assembly line, ready to hit public roads. Because of the simplified design, fewer raw materials, and in-house manufacturing, Tesla has slashed its production costs dramatically. Whether those savings are passed to consumers or absorbed as margin, one thing is clear. When Tesla unveiled its new carbon-wrapped motor, it wasn't just an innovation, it was a punch to the gut, because while Tesla was quietly engineering the future, most of the competition was busy playing catch-up to its past. Just a few years ago, the electric vehicle race looked like a free-for-all. Ford, General Motors, Toyota, Volkswagen, and a crowd of well-funded startups like Rivian and Lucid were all lining up to take a shot. Billions were poured into R&D. New platforms were teased. And for a brief moment, it looked like Tesla's lead might finally crack. Then came the carbon-wrapped rotor, and just like that, the game shifted. Most legacy car makers are still building EVs on platforms originally designed for gasoline engines. That means unnecessary weight, inefficient layouts, and the kind of production complexity Tesla engineered out a decade ago. Worse still, their factories are still tied to outdated supply chains and third-party manufacturers. Need a battery? Call LG. Need a motor? Outsource it. Need updates? Wait for a software patch from 3 teams away. Meanwhile, Tesla designs everything in-house: motors, batteries, software, chips, and builds them all under one roof. Let's look at the scoreboard. Ford promised $50 billion in EV investment by 2026. Its Mach-E SUV still weighs over 300 pounds more than a Tesla Model Y. In Q1 2025, Ford lost $1.3 billion in its EV division. General Motors committed $35 billion to electrification. Their vaunted Ultium platform rollout has been plagued by delays and software issues. Many battery packs are still assembled manually, killing efficiency. Toyota announced a $38 billion EV strategy, but is now pivoting back to hybrids after slow sales. Its flagship EV, the BZ4X, was recalled for wheels that literally fell off during testing. Volkswagen lost over $7.5 billion through its software division, Cariad, in 2022. Key models like the electric Porsche Macan are delayed, and morale is reportedly plummeting across development teams. These companies aren't just facing technical hurdles, they're facing structural problems, the kind that don't go away with press releases. Startups were supposed to be different, nimble, innovative, disruptive. Instead, most of them are burning through cash like a rocket without fuel. Lucid Motors, the Lucid Air, a stunning car, no doubt, but at a base price of around $150,000. It's more concept than consumer option. In 2024, Lucid delivered just over 10,000 vehicles. It lost nearly $3 billion, despite massive backing from the Saudi Public Investment Fund, which now owns over 60% of the company. Rivian, their trucks are rugged, their fans loyal, but their scaling issues are brutal. In 2024, they delivered around 50,000 vehicles, far below projections. The real kicker? They reportedly lose about $40,000 per vehicle sold. Even with a positive gross margin one quarter, long-term profitability is still miles away. BYD, build your dreams. China's EV juggernaut delivered over 4.2 million plug-in vehicles in 2024, surpassing Tesla in raw volume. But there's a catch. Most of them are low-cost hybrids and budget EVs, many selling for under $25,000. Their profit margins per vehicle? Tiny. Outside of China, their presence is still weak, just 240,000 exports in 2024. Now, growing trade restrictions in Europe and the US are squeezing BYD's ability to expand globally. If the new motor was the bullet, Tesla's software is the sniper rifle. Most automakers still treat software like an add-on, something you patch later. Tesla treats it as the core operating system, a dynamic brain constantly learning and improving. Its full self-driving FSD AI is trained on more than 3.6 billion miles of real-world driving data. Compare that to General Motors' Super Cruise, which has logged just 300 million miles. That's like comparing a seasoned pilot to someone who just got their learner's permit. Tesla doesn't just gather data, it uses it. At speed, updates roll out every few weeks, not quarterly, and because every Tesla is internet connected, improvements happen overnight while you sleep. This ability to learn, adapt, and push changes at global scale is something no one else in the auto industry can replicate right now. What we're witnessing isn't just a tech race, it's a paradigm collapse. While legacy automakers are still figuring out how to survive the transition, Tesla is already on to phase 2. While startups are bleeding capital, Tesla is generating margin. While others debate which plug to use, Tesla made its connector the new North American standard. And all of these motors, batteries, factories, software, charging is part of a system designed not just to perform, but to dominate. Tesla isn't reacting to the market anymore, it's creating the market. While other automakers scramble to scale, Tesla was already going global at warp speed. Electric vehicles aren't just about batteries and motors, they're about factories, logistics, precision, volume. In a world racing towards electrification, whoever builds fastest and smartest wins. And Tesla is building an empire. Let's rewind to 2019. Tesla broke ground in a barren lot on the outskirts of Shanghai, China. People laughed when Elon Musk said it would be building cars there within a year, because that's not how factories work, until it did. By the end of 2020, the Shanghai Gigafactory was already rolling out vehicles, ahead of schedule and under budget. Fast forward to today, that same plant now produces over 750,000 vehicles a year, making it one of the largest EV factories on Earth. And here's the jaw-dropper: Tesla owns it outright. No joint venture, no local partner, just full control, something unheard of for a foreign automaker in China. This wasn't just manufacturing, it was a declaration of capability, a blueprint for what was to come. Next stop, Berlin. In 2022, Tesla opened Gigafactory Berlin, deep in the heart of Germany, Volkswagen's backyard. Within 2 years, the plant was producing 500,000 Model Y vehicles annually. That's nearly 5,000 EVs per week, faster than most legacy competitors can even ship parts. All this from a company that many European carmakers once dismissed as a Silicon Valley side project. Now, Tesla was building faster, cheaper, and better, right next door. Back home, Gigafactory Texas, aka Giga Austin, was rising like a steel giant. Using custom-made gigapresses, Tesla began casting massive vehicle sections in under 2 minutes, radically reducing parts, labor, and cost. By 2025, the factory had already produced over 400,000 vehicles, with a projected capacity to exceed 600,000 annually. Combined with its Fremont facility in California, Tesla's U.S. capacity now hovers near 1 million units a year. That's more than Rivian, Lucid, and Fisker combined. And Elon Musk wasn't done.
Probably the most significant announcement of the day is that we're excited to announce that we're going to be building a Gigafactory in Mexico.
In 2025, Tesla announced a bold new leap, a $10 billion Gigafactory project in Nuevo León, Mexico, just a few hours from the Texas border. Planned to open by 2026, the factory is expected to create over 20,000 jobs and produce Tesla's next-generation vehicle platform, cheaper, faster, and even easier to scale. Mexico offers a perfect storm: proximity to the US, lower labor costs, and access to key battery materials. For Tesla, it's not just about expansion, it's strategic global integration. While legacy automakers wrestled with production line updates, Tesla quietly moved into entirely new continents. In 2024, Tesla opened its first major hub in Santiago, Chile, a showroom, service center, and supercharging station all in one. In 2025, Tesla launched a flagship location in Riyadh, Saudi Arabia, with more sites planned in Jeddah and Dammam. The same year, Tesla began negotiations with the Indian government to build a factory and sell imported vehicles under India's new EV-friendly import policy. Tesla isn't just chasing demand, it's creating it, embedding infrastructure before competitors even set foot on the ground. What really sets Tesla apart isn't just where it builds, but how. Every Tesla Gigafactory is packed with automation, high-speed production lines, and custom hardware. Giant die-casting machines, known as gigapresses, shape parts of the car frame in seconds. Robots and AI coordinate logistics inside the factory floor. Tesla's future factories won't just build cars, they'll assemble them like Lego. In 2024, Tesla filed a patent for a new production concept, building vehicle sections simultaneously, then snapping them together at the end of the line. If it works at scale, this could cut factory size in half and double speed. Think of it like app development: modular, agile, fast, repeatable. Tesla's making cars like software companies make updates. Then there's the sales model. While other brands still rely on dealerships, commissions, and third-party service centers, Tesla went full digital years ago. You don't haggle, you don't wait. You pick your car, click order, and have it delivered to your door. And when something breaks, software updates fix most issues overnight. No trip to the shop needed. According to Tesla's internal data, the average car spends less than 10 minutes per year at a service center. No middlemen, no markups, no wasted time. Tesla isn't just building cars, it's building an operating system for transportation, a fully integrated chain from raw materials to road-ready EVs, all coordinated under one roof. While others play catch-up in one region, Tesla is deploying factories across 3 continents and preparing to disrupt a 4th. This is what dominance looks like in the EV age. Not just a good car, not just a fast car, but a global machine that scales innovation faster than the world can react. While everyone else debated plug types, Tesla was building an empire. Long before most automakers took electric vehicles seriously, Tesla was solving a problem they hadn't even begun to think about. Charging, range anxiety, long waits, broken stations, confusing apps. That was the norm. Tesla changed all of it with the Supercharger network. The first Supercharger station opened in 2012, a time when most car companies were still showing off futuristic EV concepts that never left the stage. Tesla, on the other hand, was already installing fast-charging infrastructure across highways. People called it a nice perk for early adopters. It wasn't a perk. It was a 10-year head start. Today, that early bet has grown into the largest and most reliable fast-charging network on Earth. As of early 2025, Tesla operates more than 7,100 supercharger stations globally, with over 67,000 individual stalls. No other network comes close. This isn't just about quantity, it's about quality. Tesla superchargers aren't your average plug-and-pray stations. They're engineered end-to-end by Tesla, from the software to the cables to the charging logic. That means no broken chargers, no app downloads, no QR codes, no guessing which plug fits your car. Just pull in, plug in, and go grab a coffee. Tesla reports a 99.97% uptime across its network. That's better than some airlines, hospitals, and yes, other EV networks. If you're a Tesla driver, charging is almost an afterthought, and that's exactly the point. Tesla's current V3 superchargers deliver up to 250 kilowatts, adding around 200 miles of range in 15 minutes. But that's already being replaced by V4 superchargers, which push speeds to 325 kilowatts, with built-in CCS adapters, credit card readers, and support for non-Tesla EVs. Yes, you heard that right. Non-Teslas are now welcome. In 2023, Tesla struck a landmark deal with the U.S. government. In exchange for federal funding under the NEVI National Electric Vehicle Infrastructure Program, Tesla agreed to open at least 7,500 supercharger stalls to other EV brands. By the end of 2024, over 3,500 stations had been opened up. Suddenly, Tesla wasn't just powering its own cars, it was powering the entire industry.
By the end of 2024, Tesla will open 3,500 new and existing superchargers along highway corridors.
For years, Tesla used its own slim, elegant connector, while everyone else wrestled with bulky CCS or CHADEMO plugs. Then, in late 2022, Tesla made a move that changed North American EV charging forever. They gave their plug a name, NACS, the North American Charging Standard. It sounded like branding until everyone adopted it. In just 18 months, the dominoes fell. Ford, General Motors, Rivian, Volvo, Mercedes-Benz, Hyundai, Toyota, Nissan, and more all agreed to switch to Tesla's NACS plug starting in 2025. Suddenly, the once proprietary Tesla connector became the de facto standard for the entire continent, and with it came access to Tesla's massive Supercharger network. Tesla wasn't just dominating cars anymore, it was quietly cornering EV infrastructure. Let's talk about money. Every time a Ford F-150 Lightning or Hyundai Ioniq 5 charges at a supercharger, Tesla makes money. They don't have to sell the car. They don't have to service it. They just own the plug and the profit. By 2028, analysts predict non-Tesla vehicles will make up a third of all supercharger sessions in the US.
As of right now, the Tesla Superchargers are only open to Ford vehicles, but Rivian is supposedly going to be able to start charging later this year.
That's a whole new revenue stream, one Tesla controls from top to bottom. In Europe, where the CCS2 plug is standard, Tesla adapted quickly. Most superchargers on the continent now feature dual cables, welcoming both Teslas and non-Teslas. In countries like France, Germany, and the Netherlands, it's now normal to see different EV brands charging side by side under Tesla canopies, just like a petrol station, but smarter, faster, and cleaner. In China, the supercharger footprint is smaller, but growing fast. In 2024 alone, Tesla recorded over 60 million charging sessions in China, twice as many as the year before. This isn't just a network, it's a habit, one that's spreading like wildfire. Tesla isn't stopping at stalls. The next generation of supercharger locations, known as mega sites, are already being built with over 100 charging stalls per location, solar canopies for renewable power, megapack battery storage to reduce grid strain. Some of these sites are more than charging stations. They're mini power plants, feeding clean energy into both cars and the local grid. Tesla designs its charging network the same way it builds its vehicles: custom hardware, seamless software, regular updates, zero middlemen. Need to fix a bug? Tesla pushes an update overnight. Want to improve speed? Tesla tweaks the algorithm. No phone calls, no maintenance truck, just code. That's what makes the supercharger network more than infrastructure. It's an ecosystem, one that other companies now depend on. While competitors struggle to sell EVs and build their own networks, Tesla built the roads, laid the cables, installed the stations, and then charged everyone else to use them. Tesla didn't just win the EV war, it built the battlefield. Forget everything you know about electric vehicles. This is where the story turns sci-fi. While the world was dazzled by Tesla's speed, range, and charging network, something far more powerful was brewing deep behind the scenes. A machine so advanced, so custom-built, it's changing the way cars learn to drive. It's called Dojo, and it may be the most important thing Tesla has ever created. Tesla's secret weapon isn't just electric motors or software updates, it's intelligence at scale. Every Tesla on the road is essentially a camera-equipped robot, recording the world in real time. Traffic lights, pedestrians, accidents, wild weather, unpredictable chaos. While other automakers test self-driving tech in closed environments, Tesla is learning from reality on highways, in suburbs, across cities, around the globe. But here's the problem. That level of learning creates unimaginable amounts of data, millions of miles worth of video every hour. Normal data centers would choke. So Tesla did what no one else dared. They built their own AI supercomputer from scratch. First unveiled at AI Day in 2021, Dojo isn't just another server farm. It's a bespoke supercomputer engineered specifically to train Tesla's neural networks using full-frame video, not simplified simulations. At its core lies the D1 chip, a silicon beast designed by Tesla's in-house team. It holds 50 billion transistors, 354 processing cores, built on a 7-nanometer process by TSMC. And that's just one chip. Tesla fuses 25 D1 chips together into a single training tile. about the size of a large pizza box. Each tile can move 36 terabytes of data per second and crunch 9 petaflops of computation. That's more processing power than most supercomputers. Stack 6 tiles and you get a tray. Stack 2 trays and you get a cabinet. Stack 10 cabinets and you get what Tesla calls an exapod, a computing monster unlike anything the auto industry has ever seen. Tesla's exapod packs over 1 million processing cores, wired into a nervous system of high-speed memory that moves data faster than your brain can blink. But here's the headline. It crushes the exaflop barrier, performing more than 1 million billion calculations per second. That's enough to simulate an entire digital planet, and Tesla is using it to teach cars how to see, think, and drive better than humans. Unlike traditional companies that use synthetic simulations to train their self-driving systems, Tesla feeds Dojo with raw video from its fleet. Every time a Tesla sees something weird, a dog riding a skateboard, a construction worker waving traffic, a flipped truck on the highway, it captures that moment and sends it home. Dojo doesn't just store that footage, it learns from it. Engineers say Tesla now collects the equivalent of 1 million driving miles per hour. Dojo ingests it, processes it, and turns it into smarter decisions for the entire fleet. Dojo is more than a supercomputer. It's a hive mind, one that grows stronger with every mile driven. Here's why this matters. Most companies depend on chips from NVIDIA or other third parties to train their AI. But those chips are expensive, sometimes $30,000 or more each, and the waitlist can stretch over a year. Elon Musk called it a financial death trap. So Tesla skipped the line. They built their own silicon and now they control everything. The chips, the data, the software, and the pace. That independence means no supply chain bottlenecks, no licensing fees, no delays. It also means Tesla can do something else, turn Dojo into a business. Analysts from Morgan Stanley estimate that Dojo alone could unlock over $500 billion in future value, especially if Tesla decides to rent its training power to other AI firms. Imagine that, Tesla becoming not just a car company, but a cloud AI giant. The real kicker? Dojo isn't limited to self-driving. The same neural network platform can be used to train humanoid robots, like Tesla's Optimus project. Optimize energy usage across solar and battery networks, power AI-driven factory automation, and even assist in medical, defense, or logistics AI applications. It's all running on the same architecture. If Tesla controls the brain that trains everything, they don't just build the future of driving, they build the future. For the average Tesla driver, Dojo is invisible. No dashboard alert, no visual interface, no app. But what do you notice? Smoother lane changes, faster reactions at roundabouts, sharper braking in the rain, a car that drives just a little smarter every single morning. All thanks to a machine you'll never touch, doing calculations you'll never see at a speed humans can barely comprehend. This isn't just software, this is evolution on autopilot. So there you have it. Tesla didn't just build a better EV, it built the ecosystem, the infrastructure, and the AI brain to power it all. While others chase, Tesla leads. This isn't a competition anymore, it's domination. But what do you think? Is Tesla unstoppable, or is a real challenger just around the corner? Let us know in the comments, and don't forget to like, share, and subscribe for more game-changing stories from the edge of innovation.